So today let's discuss questions related to cylinder. So the question 1 says that find the equation of right circular cylinder which passes through the circle formed by intersection of this sphere and the given plane. So the given sphere is basically x square plus y square plus z square is equals to 9, and the given plane is x minus y plus z is equals to 3. So if let's say this is my sphere and this is basically my equation of plane, so this is the intersection formed by this is the circle formed by intersection of the sphere and the plane. So the cylinder which I'm supposed to find will be something like this. So this is basically my cylinder which I'm supposed to find, and this is the axis of cylinder. So if you observe that axis of cylinder is perpendicular to plane or the circle which was formed by intersection, and by the equation of circle, direction cosines of normal to the plane are 1, minus 1, 1. So if these are direction cosines of normal to the plane, so direction cosine of axis of cylinder will be proportional to these, will be proportional to 1, minus 1, 1. So these are basically so my direction cosine of axis of cylinder will be proportional to these. So now let us assume that alpha, beta, gamma be any point on cylinder. Then equation of generator of cylinder would be equation of generator or cylinder would be basically x minus alpha upon 1 is equals to y minus beta upon minus 1 equals to z minus gamma upon 1. So this will be basically my equation of generator of cylinder, because generator of cylinders are also parallel to the axis of cylinder. Also let us assume that it's r distance away from axis. So let us equate with r and find any arbitrary point lying on cylinder. So any point on cylinder will be basically r plus alpha minus r plus beta and r plus gamma. So this is basically any arbitrary point lying on the cylinder. So if this is any arbitrary point lying on the cylinder, then for some value of r, this point must satisfy the equation of circle. So if that's the case, this point must satisfy equation of both plane and equation of the sphere for some value of r. So we'll be basically substituting this point in equation of plane and cylinder. So if we substitute this plane in equation of plane, this point in equation of plane, which is basically x minus y plus z is equals to 3. So from here I got r plus alpha minus r plus beta plus r plus gamma is equals to 3. So if I simplify it, I'll get 3r plus alpha minus beta plus gamma is equals to 3. So from here I'll get my value of r. So r is basically 3 minus alpha plus beta minus gamma divided by 3. So this is basically my value of r, for which any point on generator is satisfying the equation of plane. Now it must satisfy the equation of sphere as well. So using that I'll get r plus alpha square plus minus r plus beta square plus r plus gamma square is equals to 9. So let us just simplify the equation on left hand side. So using that I'll get 3r square plus alpha square plus beta square plus gamma square plus 2r alpha minus 2r beta plus 2r gamma is equals to 9. So if I further simplify it, I'll get alpha square plus beta square plus gamma square plus 2r into alpha minus beta plus gamma plus 3r square is equals to 9. Now for this value of r, it must satisfy equation of sphere as well, because this is the value of r when the plane and the sphere will be intersecting to form the circle. So substituting this value of r here, and we'll get alpha square plus beta square plus gamma square plus 2 into 3 minus alpha plus beta minus gamma by 3 into alpha minus beta plus gamma plus 3 into 3 minus alpha plus beta minus gamma by 3 whole square is equals to 9. So if I further simplify it, I'll get 3 into alpha square plus beta square plus gamma square plus 2 3 minus alpha plus beta minus gamma into alpha minus beta plus gamma plus, if I'll take whole square in the denominator, so once they'll balance out 1 in denominator, so I am left with 3 minus alpha plus beta minus gamma square is equals to 9 into 3. The 3 in denominator, I am taking it to right hand side. So what I am left with 3 alpha square plus beta square plus gamma square plus, now what I can do is I can take out one of these terms. I can take common this term from both these, so I'll get 3 minus alpha plus beta minus gamma into 2 alpha minus 2 beta plus 2 gamma plus 3 minus alpha plus beta minus gamma is equals to 27. So this is also equivalent to 3 of alpha square plus beta square plus gamma square plus 3 minus alpha plus beta minus gamma into 2 alpha minus alpha minus 2 beta plus beta is minus beta and 2 gamma minus gamma is gamma plus 3 is equals to 27, which is also equivalent to 3 alpha square plus beta square plus gamma square plus 3 into, I can write this term as minus of alpha minus beta plus gamma into 3 plus of alpha minus beta plus gamma is equals to 27. So if you observe that it is somewhat like a minus b into a plus b, so I can write it as a square minus b square. So it will reduce to 3 into alpha square plus beta square plus gamma square plus 3 square minus alpha minus beta plus gamma square is equals to 27. So if I simplify it further, I'll get 3 of alpha square plus beta square plus gamma square minus, I'm opening this square, whole square, I'll get alpha square plus beta square plus gamma square minus 2 alpha beta minus 2 beta gamma plus 2 alpha gamma is minus 3 square 9, and my 9 minus 27 is basically 18. So I was left with 2 alpha square plus beta square plus gamma square minus, no, it's minus plus 2 alpha beta plus 2 beta gamma minus 2 alpha gamma minus 18 is equals to 0. I can divide the whole equation with 2, so I'll get alpha square plus beta square plus gamma square plus alpha beta plus beta gamma minus alpha gamma minus 9 equals to 0. But if you remember that alpha comma beta comma gamma we assumed as any arbitrary point on the cylinder. So if alpha beta gamma is any arbitrary point, so this is basically my locus of cylinder. So equation of cylinder passing via a sphere, that is x square plus y square plus z square equals to 9, and plane x minus y plus z is equals to 3 is x square plus y square plus z square plus xy plus yz minus xz minus 9 equals to 0. So this is basically my equation of cylinder which is passing via circle, which is basically intersection of the plane and the given sphere. So this is what we are supposed to prove. So let's move on to next question. So the next question says that find the equation of cylinder whose generator intersects this curve and the generators are parallel to this line. So the given line is 3x equals to minus 2y is equals to 4z. So I can divide the whole equation of line by 12. So I'll get x by 4 is equals to y by minus 6 equals to z by 3. So it is given that generator of cylinder are parallel to this line, parallel to let's say 1. So from here direction cosines of generator of cylinder will be proportional to 4, minus 6, 3. So if I assume that let alpha, beta, gamma be any arbitrary point on cylinder, then equation of generator will be basically x minus alpha upon 4 is equals to y minus beta upon minus 6 equals to z minus gamma upon 3. So if I equate it with r, so I can get any arbitrary point on the generator of the cylinder. So any arbitrary point on generator of cylinder would be 4r plus alpha minus 6r plus beta 3r plus gamma. So this is basically any arbitrary point on the cylinder. So if this is any arbitrary point on the cylinder, then it is basically any arbitrary point on the generator line. And in the question it is given that the generator line intersect these curves. So if generator line intersect these curves, then this point must satisfy equation of the given curve. So using that I'll get 4r. So this must be satisfying x minus y plus 2z equals to 3 and 2x square plus 3y square is equals to 4z. So we'll substitute value of this arbitrary point in this to find out the value of r. So if we do so, we'll get 4r plus alpha minus 6r plus beta plus 2 into 3r plus gamma is equals to 3. So if I simplify it, I'll get 4r plus 6r, 10 plus 6, 16r plus alpha plus beta plus 2 gamma is equals to 3. So from here I can find out value of r, that would be r is equals to 3 minus alpha minus beta, here it is minus beta, minus alpha plus beta minus 2 gamma divided by 16. So I got my r as 3 minus alpha plus beta minus 2 gamma divided by 16. Also this arbitrary point must be satisfying the equation of second curve, which is basically 2x square plus 3y square is equals to 4z. So if I substitute this value of r, this arbitrary point here, I'll get 2 into 4r plus alpha square plus 3 into minus 6r plus beta square is equals to 4 times z, that is 3r plus gamma. So if I simplify it, I'll get 2 into 16r square plus alpha square plus 8r alpha plus 3 into 36r square plus beta square minus 12r beta is equals to 12r plus 4 gamma. So I can club in coefficients of r square, r and the constant terms. So if I do so, I'll get 32 plus 36 into 3, which is basically 10872 plus 36, 108. That's coefficient of r square, plus coefficient of r is basically 16 alpha minus 12 is a 36 beta minus 12. This is coefficient of r, plus 2 alpha square plus 3 beta square minus 4 gamma is equals to 0. Now I can substitute value of r here. I'll get 32 plus 108, which is basically 140. So it is 140 r square, which is 3 minus alpha plus beta minus 2 gamma by 16 whole square plus 16 alpha minus 36 beta minus 12 into 3 minus alpha plus beta minus 2 gamma by 16 plus 2 alpha square plus 3 beta square minus 4 gamma is equals to 0. So I can take this term out. So I'll get 3 minus alpha plus beta minus 2 gamma by 16 as common. So I was left with 140 into 3 minus alpha plus beta minus 2 gamma divided by 16 plus 16 alpha minus 36 beta minus 12 plus 2 alpha square plus 3 beta square minus 4 gamma is equals to 0. So if I simplify it, I'll get 3 minus alpha plus beta minus 2 gamma divided by 16, and from here I'll get 4, 3, 5. So it is basically 35 into 3, 105 minus 35 alpha plus 35 beta minus 70 gamma plus 64 alpha minus 36 into 4, 144 beta minus 48 plus 2 alpha square plus 3 beta square minus 4 gamma is equals to 0. So if I simplify it further, I'll get 3 minus alpha plus beta minus 2 gamma by 16 into 105 minus 48, which is basically 57, and 64 minus 35, which is 29 alpha, and 35 minus 144, which is basically my 109 beta minus 70 gamma divided by 4 plus 2 alpha square plus 3 beta square minus 4 gamma is equals to 0. So from here we'll get 3 minus alpha plus beta minus 2 gamma into 57 plus 29 alpha minus 109 beta minus 17 gamma plus 64 into 2 alpha square plus 3 beta square minus 4 gamma is equals to 0. So we can simplify this further to get the equation of a required cylinder. So let's move on to next question. So the next question says that find the equation of cylinder whose generator are parallel to this line and whose guiding curve is. So guiding curve is x square plus 2y square is equals to 1, comma z equals to 0. So, and it is given that generators are parallel to line x by 1, y by minus 2 is equals to z by 3. So direction cosines of generators are proportional to 1 comma minus 2 comma 3. So if alpha comma beta comma gamma is any point on cylinder, then equation of generator would be basically x minus alpha upon 1, y minus beta upon 2 is equals to z minus gamma upon 3. But it is given that guiding curve is this, so generator must be meeting guiding curve to form the equation of cylinder. So on generator line my z must be is equals to 0, so I got it as x minus alpha upon 1 is equals to y minus beta upon minus 2 is equals to minus gamma upon 3. So from here I can find out any arbitrary point, which is basically intersection point of generator and the guiding curve. So that would be basically alpha minus gamma by 3 comma beta plus 2 gamma by 3 comma 0, because my z is equals to 0. So this is basically intersection point of generator and the guiding curve, so it must be satisfying this as well. So using that I'll go get x square plus 2y square equals to 1. So if I put this value herein, I'll get alpha minus gamma by 3 square plus 2 into beta plus 2 gamma by 3 square is equals to 1. And alpha comma beta, I can simplify it further. Alpha square plus gamma square by 9 minus 2 alpha gamma by 3 plus 2 beta square plus 4 gamma square by 9 plus 4 beta gamma by 3 is equals to 1. So if I simplify it, alpha square plus 2 beta square plus gamma square by 9 plus 4 2s are 8 gamma square by 9 minus 2 alpha gamma by 3 plus 8 beta gamma by 3 is equals to 1, which is basically equals to alpha square plus 2 beta square plus gamma square minus 2 alpha gamma by 3 plus 8 beta gamma by 3 is equals to 1. But we have assumed alpha comma beta comma gamma to be any arbitrary point on the cylinder. So my equation, so this will act as basically locus to the cylinder. So equation of cylinder will be 3x square plus 6y square plus 3z square minus 2xz plus 8yz is equals to 3. So this is basically my required equation of cylinder, for which the generators are parallel to this line and intersecting the guiding curve this. So let's move on to next question. So the next question says that find the equation of cylinder whose generators are parallel to this line and whose guiding curve is this. So this question is similar to the question we have done previously. So if the generators are parallel to this line, so let alpha comma beta comma gamma be any point on cylinder. So my equation of generator line will be x minus alpha upon 1 y minus beta upon minus 2 is equals to z minus gamma upon 3. So this is basically my generator line, and cylinder is formed by this as guiding curve. So this curve must be intersected by this generator line. So my z must be is equals to 2 here. So I'll get x minus alpha by 1 is as y minus beta by minus 2 is equals to 2 minus gamma by 3. So from here I can find out any arbitrary point on the generator line. So that would be basically alpha plus 2 minus gamma by 3 comma beta minus 2 into 2 minus gamma by 3 comma 2. So this must satisfy this curve as well. So if I put this arbitrary point there, I'll get alpha plus 2 minus gamma by 3 square plus beta minus 2 into 2 minus gamma by 3 square is equals to 4. So if I simplify it, I'll get 3 alpha plus 2 minus gamma square plus 3 beta minus 4 plus 2 gamma square is equals to 36. So I can simplify it further. I'll get 9 alpha square plus 4 plus gamma square, 12 alpha minus 4 gamma minus 6 alpha gamma plus 9 beta square plus 16 plus 4 gamma square minus 24 beta 16 gamma plus 3 to 6 to the 12 beta gamma is equals to 36. So from here I'll get 9 alpha square plus gamma square plus 5 gamma square plus 9 beta square, 12 alpha plus 12 alpha minus 4 gamma minus 16 gamma is minus 20 gamma minus 24 beta minus 6 alpha gamma plus 12 beta gamma and 4 plus 16 20 minus 36, that is minus 16. So from here I'll get, so this is basically my locus of cylinder, because I assumed alpha comma beta comma gamma to be any arbitrary point on the cylinder. So my equation of cylinder is basically 9x square plus 9y square plus 5z square plus 12x minus 24y minus 20z minus 6xz plus 12yz minus 16 equals to 0. So this is basically my required equation of cylinder. So let's move on to next question. So the next question says that find the equation of right circular cylinder of radius 2 whose axis is this line. So let's say this is my cylinder and this is my axis. So the axis is basically x minus 1 by 2 is equals to y minus 2 by 1 is equals to z minus 3 by 2. So this is my axis. Further it says that the radius of cylinder is 2. So let this be point x comma y comma z and this be my perpendicular from PA on the axis. Let's name it as M, and let's say this be my OM. So if you observe that it forms a right angle triangle here. So if I use Pythagoras theorem on triangle OPM, I'll get OP square is equals to PM square plus OM square. Also, if you observe that this is my equation of basically axis. So from here direction cosine of equation of axis is basically 2, 1, 2, which is basically, so actual direction cosines are basically 2 by under root 2 square plus 1 plus 2 1 square plus 2 square, which is basically 2 by 3 comma 1 by 3 comma 2 by 3. So these are my basically actual direction cosines of the axis. Further, my axis is passing via point 1 comma 2 comma 3. So this is basically any arbitrary point on 1 comma 2 comma 3. I can assume this point O to be my point 1 comma 2 comma 3, and then likewise I can locate any point P on the cylinder and its perpendicular M on the axis. So if this is my point O, then my OP using distance formula would be OP square will be basically x minus 1 square plus y minus 2 square plus z minus 3 square. So this is basically my OP, and my PM is basically a radius of cylinder, which is basically 2. It is given to us in the question. And OM is projection of OP on axis of cylinder. So my OM is basically x minus 1 into direction cosine of axis, that is basically 2 by 3, plus y minus 2 into direction cosine of axis, that is 1 by 3, plus z minus 3 into 2 by 3. So this is basically my OM, that is projection of axis on the cylinder, projection of OP on the axis of cylinder. So if I substitute value of OM, OP and PM in this star equation, I will get x minus 1 square plus y minus 2 square plus z minus 3 square is equals to PMI is 2, so 2 square plus OM is this, so square of it is 2x by 3 plus y by 3 plus 2z by 3 minus 2 by 3 minus 2 by 3 minus 6 by 3 square. So this is basically equals to x minus 1 square plus y minus 2 square plus z minus 3 square equals to 4 plus 2x plus y plus 2z minus 10 by 3 square. So if I simplify it, I'll get 9 into x minus 1 square plus 9 into y minus 2 square plus 9 into z minus 3 square is equals to 36 plus 2x plus y plus 2z minus 10 square. So this is basically my required equation of cylinder, and we can also further simplify it by opening the whole square thing, and we'll get the simplified equation of cylinder. So that's all I think. So these are the only questions related to cylinder. So thank you for watching.